Good day. Today I will be discussing about the X-ray film composition. Introduction. X-ray films help us to record the information regarding the object or tissue through which the X-rays passes, and hence they greatly help in diagnosis and treatment of the patient problem. Image recorded on film is caused by exposure to photons. X-ray film. So, history. The first X-rays were recorded in a glass plates. These were coated with emulsion on one side only. The exposure thus was quite high. In 1839, the phenomenon of development was discovered by Louis Daguerre. 1 year later, it was discovered that treating exposed silver chloride paper with sodium chloride would make the image permanent. Nitrocellulose-based film was used in 1914 for recording X-rays. This film was single emulsion but was quite flammable. It was later discovered that double emulsion responded to X-rays faster. In 1924, safety film made of cellulose triacetate replaced the nitrocellulose-based film. So, the composition. So here, first the X-ray film, it has a base, adhesive, and emulsion. In base, they have polyester, polyethylene, terephthalate, while in adhesive and emulsion, they have silver halide grains and vehicles matrix. X-ray film cross section. So as you can see here in the image, so you can see the supercoat, emulsion, adhesive, the base. Yes. So next is the base on film. So it is a transparent supporting material. Polyester, polyethylene, terephthalate resin are used. Thickness is 0.18 mm. So ideal properties-based material. Structural support for fragile emulsion. Low light absorption should not produce visible pattern on the radiograph. Flexible, thick, and strong. Dimensional stability, so it maintains size and shape during processing, handling, and storage. It is non-flammable. Tinted film. So the triacetate and polyester are clear and colorless. Adapted in 1933, blue tint was added to the X-ray film in an effort to produce a film that was easier to look at. So causes less eye strain. Blue tint can be added to either to the base or to the emulsion. All present X-rays films are blue tinted. Functions as base. Provides support for emulsion layer to transmit light. So adhesive layer, also called sobbing layer or substratum layer. It is made of mixture of gelatin solution and solvent of film base. It keeps emulsion layer and base adhered to each other during coating stage and processing. It provides uniform surface over which the emulsion can be coated uniformly. Next is the emulsion layer. It has two principal components, the silver halide grains and vehicle matrix. It consists of a homogeneous mixture of gelatin and silver halide crystals. In typical emulsion, close to 99% is AgBr and about 1 to 10% AgR. So the presence of AgR produces an emulsion of much higher sensitivity than a pure AgBr emulsion. It also contains traces of sulfur alethiorea. How silver halide crystals are made. So it dissolves metallic silver in nitric acid to form silver nitrate by mixing silver nitrate plus KBr, Ag2Br plus potassium nitrate. So silver halide in emulsion is in form of small crystals. Silver halide crystals may be tabular, tubular, polyhedral, or irregular shape. So crystal size might vary from 1.0 to 1.5 microns in diameter with about 6.3 by 10 grains per centimeter of emulsion. So as you can see here in the image, the dark one circle is the Ag plus the Br, and in the circle that having an X is the I. The clear one circle is the Br. So, an imperfect crystal. Perfect crystal has almost no photographic sensitivity. Several types of crystal defects noted. Crystal defects. So, a point defect consists of a silver ion that has moved out of its normal position in crystal lattice interstitial ions. So a dislocation is a line of perfection in the crystal. It causes strain in the wall structure. So iodine ion strains the crystal in this way. So as you can see there in the picture, it shows the dislocation line. So the chemical sensitization of the crystals are produced by adding alithiorea, a sulfur-containing compound, to the emulsion. These which reacts with silver halide to form silver sulfide. The silver sulfide is usually located on the surface of the crystals and is referred as sensitivity speck. It is the sensitivity speck that traps electrons to begin formation of the late image centers, sensitivity specs. So here shows the latent image. So the latent image, remnant radiation interacts with the silver halide crystals, mainly by the photoelectric interaction. The energy deposited into the film is in the same pattern as the subject that was exposed to radiation. This invisible image is known as the latent image. A latent image on photographic radiograph film is an invisible image produced by the exposure of the film to light radiation. By chemically processing the latent image, it is made visible, known as the manifest image. The formation of latent image. So, metallic silver is black, so it is this metallic silver that produces black areas on the developed films. Exposure of silver iodobromide grains to light photons emitted by screen direct X-ray exposure initiates the formation of atomic silver to form a visible pattern. The latent image formation in Garnier-Mott. Energy absorbed from light photon ejects Br electron. Electron trapped at sensitivity speck where it is trapped and temporarily fixed. Negative electron attracts interstitial Ag plus ion. Ag plus and E negative combine to form neutral black Ag. If 6 to 10 Ag accumulated speck, it becomes a latent image center, like it is developable. Garnier-Mott hypothesis. So this process repeats. So as you can see here in the image, it is the formation of the latent image. Grain size and distribution. The grain size and distribution affects the following. First, the speed. It is the bigger the average grain size, the higher the speed of the film. In contrast, affected by size distribution, the more available in the film, the lower the contrast. In graininess, graininess is the apparent clumping of the crystal as seen on the radiograph. The bigger the crystal, the higher the graininess of the film. Gelatin. Gelatin is used today as the suspending medium and binding agent for the silver halide particles. It comes collagen fiber in which primary sources are the cartilage, skin, and the protein matrix, the ossen of bone of animals. So why we use gelatin as binder? So it is a medium in which silver nitrate and sodium bromide can react, and the resulting AgBr get finely and evenly dispersed and remain suspended. In warm state, it can be easily spread on the film base. On cooling, it sets firmly on the base as gel. It is flexible and does not crack easily on bending. It is optically transparent. Gelatin does not react chemically with the silver halide. It is porous, so the processing chemicals can penetrate to the silver halide crystals. Some of the constituents in gelatin enhances the activity of silver bromide, and some act as antiphylline. Supercoat or the overcoat. It is the protective layer of gelatin. The supercoating. It provides sturdiness to an radiograph film. Anti-static. Reduces damage from scratches, pressure, or contamination during storage, handling, and processing. Few additives, so preservative, phenyl as bactericide, silver iodide, to extend sensitivity towards blue range. Some dyes may extend color sensitivity further. Glycerin to make the emulsion pliable. Saponin to make the emulsion receptive to the processing chemicals. Alcohol to prevent frothing during coating. Types of X-ray film. So according to their uses, intraoral films, in periodical films, so number 0, children, number 1, anterior adult, and number 2, standard adult. It is occlusal films and as biting films. And second one is the extraoral films. So, according to speed, slow film, speed A, speed B, and speed C. In fast film, it has a D ultra speed, E ecta speed, and F ultra ecta speed, and D hyperspeed G. Next is the according to emulsion layer. It is single coat or double coated. According to packaging, it is single film packet or the double film packet. Types of X-ray film based on their applications. First, the screen film. So these screen films most commonly used, sensitive to blue light emitted by intensifying screens and direct actions of X-rays, used in cassettes with intensifying screens and high speed. Non-screen direct exposure films has thicker coat of emulsion used without intensifying screen, depends mainly on action of X-ray 4 times faster than that of screen films, so requires 1/4 exposure only, must be manually processed because of a thick emulsion. Uses: first, in limb radiography, second, to detect intraocular foreign body, third one is in dental with intraoral cardboard. Third one, the mammography film, single-coated, fine-grained, slow speed, high contrast, designated to be used with single intensifying screen. Combination must be fast to deliver a minimum dose to the glandular tissue. Next, the duplicating film. It is used to copy radiograph. Original cassette to be copied is inserted into a cassette whose opaque front has been replaced by pane of clear glass. Special duplicating film is placed with emulsion side down onto radiograph and lid closed. Exposure made. So what is speed of X-ray film? So it is defined as the amount of the radiation required to produce the radiograph of adequate density. Slow film requires more exposure and vice versa. Factors affecting film speed: the size of crystal, shape of grains, thickness of emulsions. Difference with single-coated and double-coated X-ray film. The characteristic: emulsion layer, patient radiation dose, radiograph detail, average gradient G, parallax effect, and contrast. So, in emulsion layer, single-coated, it has a one side, while in the patient radiation dose, it is more, while in radiographic detail, also has more single-coated, and average gradient G, it is a very less single-coated. In parallax effect, it is no single-coated. In contrast, it is less single-coated. So, in emulsion layer, both sides is a double-coated. In patient radiation dosed, less double-coated. Radiograph detail, it is less double-coated. In average gradient G, it is more double-coated. In parallax effect, it has a double-coated. And in contrast, it is a more double-coated.